The web has become so popular over the years that it puts a considerable stress on the internet infrastructure. So much so that people call this the World Wide Wait instead of World Wide Web. You must have experienced such stalls when downloading content from YouTube or trying to buy tickets via Tatkal. There are in fact quite a few techniques that can improve web's performance. In this video, we will look at one of them, web caching. You must have already experienced web caches as part of your web browser. If you are following cricket on Cricinfo, you keep hitting that refresh button so that you get the latest scores. The web caching that I'm going to talk about in this video is something different. This is done at a much larger scale where it caters to many users. So in this method, the browsers access web via a cache. The other name for this is a proxy server. People from IIT-B are very familiar with proxy servers because we use it to access the external internet. So you can configure this proxy address and port as part of your browser's network settings. Let me quickly show you that. Here is how you configure proxies as part of your web browser. So I pulled up my Google Chrome and this is the setting. So under this, if you go down, you're going to see advanced settings. And when you go further down, you're going to see this network change proxy settings. And as part of this, there is this LAN settings. And here you can see specify the address of the proxy as well as the port. So what happens as a consequence of this is when a client wants to get a HTTP object, it is going to contact the proxy and ask for that particular object, even though this particular object belongs to some other server in the internet. And what the proxy does is if it finds the object within its cache, it responds. If it is not there within its cache, it is going to contact the designated server, request for it, get it back, and then deliver it. As a consequence of this, there are two TCP connections going to be established, one between the client and the proxy, another between the proxy and the server. So these proxy servers are installed by internet service providers. So for example, within the IIT-B campus, this is managed by IIT-B. Some companies also provide them, local ISPs also provide them. And these proxies, as I have mentioned earlier, act as servers to local clients and as a client to external servers. And internet is dense with such caches. Our own proxy server may be retrieving this content from some other cache as part of the internet service provider of IIT-B. Why should we use proxy servers? There are in fact quite a few advantages. Think of at least two. One obvious thing is that it reduces the response time of a client because you are serving the request locally. You don't have to go all the way to the server located somewhere far away. It also helps save bandwidth. You don't have to download the same content multiple times. Proxies can also help log usage, block undesired sites, so on. Something which is probably not obvious is that it enables poor content providers to effectively deliver content. Suppose you are a small organization but with a growing list of customers. You may not have enough budget to pay for the huge bandwidth costs. That way, if internet is doing caching, the number of users that come to your server is going to reduce, but at the same time, you're still reaching out to your customers. To drive home the advantage of web caching, let me go through this example. So here is an organization within this cloud with many clients. And this organization is connected to the external world with a 2 Mbps link. And let's assume that the round trip delay between this router here and some server out there in the internet going forward and coming back is 500 milliseconds. There are no proxies yet. Let's first see what happens without proxies. And these clients within the organization request objects, and let's assume the average object size is 100 kilobits, and these generate requests at a rate of 20 requests per second. This is an aggregated request rate across all the clients. So the question is, what is the average response time across all such requests? Well, this can be order of minutes because this becomes a major bottleneck. Let's look at it from this other router. So the requests have been sent out. They don't occupy that much bandwidth. It is the responses that contain these objects that will create problems, and these responses are coming from the different servers, and the rate at which the data is coming to this router is basically 20 requests per second. Each request is 100 kilobits. That means you are getting at a rate of 2 Mbps. This just about matches this bottleneck bandwidth. But then these requests are not going to come one after the other. They can be bursty, in which case your input rate is going to exceed your output rate, in which case the queue start build up, where you drive this link into congestion. Queuing theory tells that the delays in this case can be rather high. You should always operate below capacity. So to overcome this problem, one option that can be done is to increase this rate to 10 Mbps. Again, we are still not dealing with proxies. What do you think your average response time in this case going to be? A bit above 1 second, because each object takes 2 round trip times. The delay internally is assumed to be negligible. It will be just a few milliseconds. But this is going to be a costly upgrade because you now have to pay a lot more money, not just once, but every year. So proxy server to the rescue. So what you will do is you install a proxy within this organization. So all these clients go via the proxy. The proxy in turn pushes the requests if required via the router. Let's assume that you have a hit rate of 0.4. What this means is 40% of the requests can be served locally, whereas 60% of the request will have to go outside. Now, what do you think the average response time is going to be? Well, around 1 second, because your load now at this particular router is going to be 1.2 Mbps, that is lesser than the 2 Mbps, so you will not see much congestion. So 60% of the requests that go via this link are going to take around 1 second, while 40%, since you're serving locally, they'll just take a few milliseconds. When you average it out, it takes under 1 second. By the way, all these are back of the envelope calculations. You don't have to obsess whether it is 0.9 seconds, 0.7 seconds, so on. The main point is use of proxy has reduced your response time without having to go for a costly upgrade. But then there is a problem in using proxies. What do you think is this problem? Well, how do you know if the object in cache at the proxy server is still up to date? Maybe the server at the other end has changed the web page. But thankfully, HTTP 1.1 provides means to handle this via these header fields called cache control. There are in fact quite a few header fields. I'm going to show a few of them. One is what is called max age. It indicates the freshness of the particular object. So for example, when a server responds with an object, it will set max age, let's say, to 60 seconds, in which case it is telling the cache that for the next 60 seconds, this object you can serve from your own cache. You don't have to contact me. You can also specify whether an object is public, which means you can cache it, or if it is private, that means you should not cache it at the proxy. You can of course cache it at the browser. You can also specify no cache. What this means is you can cache it, but before you serve the content to the clients, you need to validate with the server. No store is even stronger. It says do not cache under any condition. This is particularly useful when you are conveying information that changes very dynamically, for example, stock quotes. So here is how such a header looks. You specify cache control, max age is equal to 3600 public. What if you notice that your cache is no more fresh? Then, as I said, you need to validate with the server, for which there are two mechanisms. One is called last modified plus conditional get. In the responses that the server sends with every object, there is a last modified information which captures time when the particular object was last modified. So when you detect that your cache is not fresh, what you basically do is you're going to contact the server through what is called a conditional get. This conditional get is like a regular get, except that it will have an additional header called if modified since. Whereas part of this if modified since, you will specify information that you have about the last modified object. I'll show an example that will make this clear. So in this example, I'm for the first time getting some information from some host XYZ. In response to this, I got this response from the server. And as you can see, it specifies when this object was last modified. And notice that I got this on November 1st, whereas this object was modified August 11th. Suppose the object in your cache is not fresh anymore and you got another request from some other client asking for the same information. Then what you do is this conditional get, where you include this information which is specifying the last modified field, which is this August field from before. And in response to this, if this object has not changed, the server will come back with a 304 not modified response, which is basically telling the cache that it can serve the client from its cache itself. Another important point to note here is this body is going to be empty. In other words, even though it asked for this HTML page, because it was not modified, you don't have to include the body. While you may have to validate often because these caches have a limited lifetime, the fact that you are not downloading the object each time can help save your bandwidth. Apart from last modified, you can also do cache validation via this eTag field. Last modified is time based, whereas eTag is hash based. Basically, the server does a hash of the contents of the object and include it in its reply, which you store. And next time contact the server with if none match by passing the tag that you have. Basically, you're storing a hash and contacting the server asking, has the hash changed? If the content has not changed, the hashes will match and thereby it will reply back with a 304 not modified status code. So whenever you receive this 304 not modified reply from a server, you can use the past cache control headers. For example, in the past reply, if max age was set to 3 days, after you receive this 304 not modified, you can continue to use the cache information for another 3 days. But if the server does not want you to serve information for 3 days, it can potentially include new cache control information where it can set max age to, let's say, 1 day when it is replying via this 304 not modified. So this is how cache validation is done as part of HTTP. So to summarize, proxy servers can help enhance web performance along with some of the other features we discussed under advantages of proxy servers. Stale caches can be a problem, but this can be handled via the cache control headers. So that's with respect to web caching.